In this video, I want to take a look at Pythagoras. Now with Pythagoras, we can only use it when we have a right angle triangle. So like we can see here, we have a right angle triangle, so we may be able to use Pythagoras. So when do we actually use Pythagoras? Well, it's when we have a right angle triangle like we've already said, and we know two of the sides and we want to work out the remaining length. Okay, so let's just state the theorem here. So Pythagoras' theorem is a squared plus b squared is equal to c squared. Okay, and this works here for when we want to work out the longest side. So that's the hypotenuse of this triangle. And the hypotenuse is always opposite the right angle. Okay, so this is the longest length here on this triangle, and we label this as C. Now the other two lengths here, it doesn't actually matter which you label as A and which you label as B. Okay, so what I'm going to do here, I'm just going to label this as A and this as B, but it wouldn't matter if we switch these around. So if this was B and this was A, we'd still get the same solution for C. Okay, so we know the values of A, we know the value of B, so we can substitute those into our formula here and obtain a value for C. So therefore, A squared, so that's going to be 3 squared, plus B squared, so if B is 4, that's going to be 4 squared. That's equal to C squared. Okay, so that's equal to C squared. What I want to do here now is simplify this left-hand side. So 3 squared is 9. 4 squared is 16. So 9 plus 16. And that's equal to C squared. Okay. Now you don't have to do this, but I like to do this. I think it makes it a little bit easier to see. So I'm going to write the C squared now on the left-hand side. Okay. That C squared is equal to 9 plus 16. I've not changed anything really. All I've done is just kind of switch where the C squared and this 9 plus 16 are. Now 9 plus 16, that would give us 25. So we know C squared is equal to 25. Okay. Now what we want here is this value here, C. Okay, we want this remaining length, BC. So if I've got C squared and we want C, we do the opposite here of squaring and we take the square root of both sides. So in that case, we get C is equal to the square root of 25, the square root of 25, and that would give us 5 there. Okay. Now, remember, we only include the positive solution here because what we're talking about is a length. So it wouldn't make sense if we got a negative length. Okay, so we just don't include the negative solution. We negate that and we don't want to include it. Now, this is actually a special example. This is what we call a Pythagorean triple, because if you notice, I've got 3, 4, and 5 here. So when I square these two lengths and add them together, the result I get is also an integer. It's a whole number. Okay, so we call this a Pythagorean triple. And there is quite a few of these. And I think we'll see a couple more as we work through this video. Okay, so the length BC is equal to 5. The other two lengths are in centimeters, so this will also be in centimeters. So 5 centimeters there. Okay, and that gives the solution to the first example. So we've worked through one example together. What I'd say here now is if you feel confident enough, have a quick go at this practice question. Again, all you're doing now is just working out this length here, AC. Notice it's the longest side. It's opposite the right angle. It's opposite the right angle. So just to give you a clue, this will be C here. So have a quick go now at part A and B, and we'll take a look in a moment at what you should have got. So hopefully you got an okay with this practice question. Let's take a look now at what you should have got. So like we said, we're looking for the length AC here. So that's this side here opposite the right angle. So we know it's the hypotenuse, the longest side in our triangle. So we label that as C. So let's just state the formula that we need. So A squared plus B squared is equal to C squared. Okay. Doesn't matter which of these we label as A, which we label as B. I'm just going to call this A and this B. Okay, but like I said, it wouldn't matter if you labeled this as B and this as A. A is 3.5, so we do 3.5 squared. We've got B squared here, so that's going to be plus 4.2 squared. And that's equal to C squared. Okay. Now we've got decimals here, which is absolutely fine to use a calculator. So I just put these into my calculator here. 3.5 squared, so that's 12.25. So 12.25 plus 4.2 squared. 4.2 squared is 17.64. So plus 17.64. And that's equal to C squared. Again, what I'm going to do here now is I'm just going to write this C squared on the left-hand side. You don't have to do this, but it's just something I like to do. And I'm going to simplify this side now. Okay, so 12.25 plus 17.64. That gives me 29.89. Okay. Now again here, all we want is this value for c. Okay, we've got c squared, we just want c. So all I'm going to do now is just take the square root of both sides. That would give me c. I'm now going to take the square root of 29.89 there. So square root I'll take the square root of 29.89, and what I get then is a decimal. So I get a decimal here, and what this gives me is 5.467, and so on. Okay. Now we want to give this answer to one decimal place, so just make sure you round this correctly here. So to one decimal place, the length of AC will be 5.5 there. Okay. And again, these two lengths are in centimeters, so this will also be in centimeters there. Okay, so the length of AC to one decimal place is 5.5 centimeters. So that's the solution to part A. Now we've got part B here as a quick follow-on, and that says find the perimeter of the triangle ABC. So remember, the perimeter here of this triangle will just be the lengths added together. Okay, so that's going to be, if I call it P here for the perimeter, that's going to be 3.5 plus 4.2 plus 5.5 that we've just worked out. So put this into your calculator again here, plus 4.2 plus 5.5, and what I get here is 13.2. Okay, so this is perimeter that we're talking about, so this will just be in centimeters because our lengths here are all in centimeters. Okay, so the perimeter of the triangle ABC is 13.2 centimeters. Now let's take a look at this example here, which is slightly different. And the reason for that is because we've already got the longest side here. So notice the side opposite the right angle. We already know that. Okay, so we already know what C is here. So what I'm doing now is I'm working out either A or B. Now it doesn't matter, remember, which one's A, which one's B. What I'm going to do is I'm just going to call this length here that we don't know A, and the other one is B. Okay, so go back to the original theorem. We say that A squared plus B squared is equal to C squared. So remember, this only works when we want to work out the longest side. We want to work out C. So what's different here now is we already know C, so this isn't going to work. So what I need to do now is just rearrange this so that we've got the letter that we need to work out, say A in this case, as the subject. So what I need to do is make A squared the subject here. I need to get rid of B squared, so the way we do that is do the opposite. So we subtract B squared off both sides. Okay. So what I'm going to get then is A squared is equal to C squared minus B squared. Okay. So we don't know what A is yet, so we just leave that as A squared. C squared, well, that's going to be 25 squared. Minus B squared, so B is 24, so minus 24 squared. Okay. So I just need to put this into my calculator here. So A squared is equal to 25 squared. So again, just put this into your calculator here. So 25 squared, that's 625. Minus 24 squared, that's minus 576 here. So I'll keep simplifying here as we go. A squared is equal, so 625 minus 576. So that's equal to 49. And remember, we just want A here. So if this is A squared and we just want A, we take the square root of both sides. So A is equal to the square root of 49, which in this case will give me 7. Okay. The other two lengths are in centimeters, so this will also be in centimeters. So we get 7 centimeters there. So the length of AB is 7 centimeters. Okay. Again, we don't include the negative solution here when we take the square root. We just want the positive one. Wouldn't make sense to have a negative length. And again, this is just an example now of a Pythagorean triple. Notice all these lengths here are whole numbers. Okay. So there we have it. So that's the solution to that example. And now it's your turn here to finish this video. So we've got one more practice question. Again, similar to what we've just done, we already know the longest side here. Notice we have the length of the hypotenuse here. So we label this as C. So have a go now, see if you can calculate the length of XZ. Okay. Remember, give your answer to one decimal place. We'll take a look in a moment at what you should have got. So hopefully you got an okay with this practice question. Let's take a look now at what you should have got. So again, I've just got a right angle triangle here. We know two of the lengths already. We know this length here and this length here. And I just want to work out this remaining length. So this one has to be C. It doesn't matter which of the other two now we call A and B. I'm going to call this one B and call this one A, just so we're working with how we did it in the last question. Okay. So remember, we know that A squared plus B squared is equal to C squared. Now, we already know the longest side, so we need to do a bit of rearranging here. So we want A squared on its own, so we subtract B squared off both sides here. So we get C squared minus B squared. Well, we know B, we know C, so we can just substitute those now into our formula. So A squared is equal C squared, that's 20 squared, minus B squared, which is 12 squared. So I get 20 squared, which is 400, minus 12 squared, which is 144. I'm just going to put this into my calculator because I am awful at mental math, so I will definitely make a mistake. So 400 minus 144, so I get 256, so A squared is equal to 256. And remember, we just want A here, we just want this length here, so therefore, we just take the square root now of both sides, so the square root of 256. Put this into your calculator again. Remember, like we can see here, this is going to give a decimal solution. Oh, we don't get a decimal solution. I must have made a mistake. So no, you should get a whole number that isn't one decimal place. So give your answer just as it is here. So the square root of 256, that gives us 16 there. Okay, so apologies about that. I'm not quite sure how that ended up like that. But we get 16 there, and these are in centimeters. So our solution will also be in centimeters. Okay, so the length xz here is equal to 16 centimeters. Okay, and that gives us the solution to our final practice question. And that brings us to the end of this video on Pythagoras.